Hello, everyone. Are you able to hear me? All right, great. Let's begin. You heard from a partner, FPT, on large-scale migrations. Um, and a lot of enterprises are migrating to the cloud for a variety of reasons. It is my pleasure to invite to the stage Bala, a senior DevOps engineer from Propertyguru, one of our esteemed customers, to share their story with us, and it brings a slightly different angle. They have had a somewhat unique journey with AWS. They were on AWS, they migrated to on-premises, and then they migrated back to AWS. So that kind of adds some kind of mystery to the whole process, right? And I can't wait to hear from Bala. Over to you, Bala.
Thank you. Hi, everybody. So I'm Bala from Propertyguru. So those who don't know about Propertyguru, we are one of the leading property platforms in online property platforms in Southeast Asia. So our objective is to help people to find their dream home. At Propertyguru, we have about 25 million visitors a month and about 2.5 million page views a day. And we have about 2 million homes listed on our website. So you can see it's not a small number. So in terms of our technology stack, we have over about 30 services and lots of technologies. And you'll see a lot of similar flavor technologies listed because we constantly evaluate and we choose what's best for us, and we keep evolving. So our journey back in 2016, we decided we want to move from AWS to on-premise, the main objective being we want to save on the operational cost. So we moved about 80% of our infrastructure to on-premise, and we ran there for about a year or so. And in 2017, we moved back to AWS. So I'll explain you why. So the main advantages of running your high traffic website on premise is that you have complete control of your environment. All the way up to the hardware level, you have complete control. And you can control when you want to upgrade and what you want to upgrade. You have the complete control over your upgrades as well. And in terms of the operational cost, it's low, but not with the same level of redundancy that you will have on the cloud. And the disadvantages being, we faced a lot of stability issues, mainly because of our custom setup. And the operational burden is really high. So in terms of the cluster management, the router management, it was really operational intensive. And it was very hard to find talent who are familiar with our custom setup as well. So these are the disadvantages we had running our infrastructure on premise. So we decided we want to move back to AWS. So we evaluated based on the cloud providers and what we need at that time, what are our requirements and the availability, the features, and we were already familiar with AWS. So AWS was a clear winner for us. So we decided that we'll move back to AWS. And how we did it, we identified the services and their dependencies first. So we drew a clear picture of the services and their dependencies. And then we took this chance to bring the whole infrastructure of ours into the code. So basically, we use Terraform to bring the whole infrastructure as code. And then we automate them using Puppet, and we also use Salt. So we did a parallel deployment on-premise, as well as launch the infrastructure using Terraform and deploy in AWS as well, and do a blue-green deployment. So you deploy parallelly and then switch slowly to cloud. So it's basically a zero downtime deployment, and we managed to migrate the whole infrastructure of on-premise to AWS in 3 months. So once we did that, our stability really increased a lot, and that's a great thing to have. After migrating, we did a lot of optimization. So the first thing we did was right-sizing the instances. So we collected metrics from CloudWatch, Datadog, and we right-sized the instances, choose the correct instance family, and we also purchased reserved instances for our production environment, so that brings the cost down as well. And then we optimized a little bit. We switched from Elastic Load Balancer to Application Load Balancer, and we revisited our bucket policies, snapshot policies, the CDN distributions, and we also use auto scaling, and we moved from we moved to managed services, for example, managed Redis, and so on. So what this gave us, we actually saved a lot of cost. So we ran more services and saved about 30% of our bill uh, than we spent before in AWS. So that's quite a lot of money, and we constantly keep optimizing our infrastructure, and this is not a one-time effort. We constantly keep doing it, so we keep our costs on tab. Um, so the final thing I want to share with you guys is that if you are running a high traffic website on premise, managing your own infrastructure is really operation intensive. And if you are running running it on cloud, AWS makes it so easy. And as you may think, migrating to AWS is not that difficult. And cost optimization exercise is not a one-time effort. It's a constant effort that you need to take care of. So that's it. Thank you, guys.
Thank you, Bala. Before you go, you say cost optimization is an ongoing exercise. Is it hard? Is it like very difficult to constantly optimize your costs?
No, I would say it's the first step. It will be a little difficult. So the first step I would suggest is to have all the resources of yours properly tagged, so you'll have a better visibility of where exactly your money is being spent. So once you do that, you will have a better visibility, and then from there, it's just it's easy. It's easy.
So visibility is
Yeah,
the key,
yeah.
and you can do it by cost allocation tags and.
Yes.
Right. Thanks for sharing, ladies and gentlemen. Bala from Propertyguru.
Thank you.
I'll see you downstairs, Bala.
Thank you.
The most fascinating thing for me when I spoke to Bala and been working with him for a bit was the degree to which they rely on automation to reduce their operational burden. And in fact, he's here giving a talk while his team back there, they're going through a new release, a major new release, and is totally not worried because he has everything set up, automated, end-to-end, well-tested, and yeah, he's here without a care in the world. So at this point, you may be wondering, well, my organization is a bit different. The applications I run are a bit different. My internal organizational structure looks a bit different. So how do I migrate at scale? Well, there are multiple approaches. You heard from a partner earlier. At AWS, we have been working over the last few years with thousands of organizations doing migrations, really, and we have done several hundred really large-scale migrations. And we have been learning and refining the techniques, and some of those you saw from our partners as well. And we put together a migration acceleration program. It is a holistic approach. It brings together a methodology about which I'll talk in a bit. Not just that, we have a robust set of tools that automate the most common scenarios and accelerate your migration journey. We have a large and growing ecosystem of partners who have been vetted to have the experience and the skills to help you along in your migration journey. AWS has a professional services team. We are constantly working with customers, and when we see new kinds of scenarios and patterns and best practices, we take those lessons and we put them back into this program and make it available to everybody. We have a specific training program targeted at IT professionals to help them understand and execute migrations. And finally, we understand that migrations are expensive, right? We have an investment model where we contribute with financial benefits to help you with your additional expenses as well. Let's take a look at the migration framework. It's a phase-based approach, and there are specific things and concerns to take care of in each phase, and the output of each phase goes into becomes input to the other. If you have done a large-scale replatforming exercise, the phases will look familiar. What I'm not going to go into is the details of each phase. We have a session later on in the day where we will take that migration framework and we'll apply it to a specific use case, and we'll talk about one of the harder things to migrate, which is data and databases. I'd encourage you to attend that session if you are interested in knowing what exactly do we do in each of the phases and what are the inputs and outputs of each of those steps that I showed you. What I want to talk about is something a little bit different. You have heard multiple speakers tell you already that migrations help them save costs, improves the reliability, reduces operational burden, improves security. I put it to you that migrations are a great opportunity to change your IT organization and enable it to deliver business value faster. And why do I say that? Different organizations are, of course, going to be different. Here's a very high-level view of, you may call it the recipe for an IT organization, right? You have the support groups at the top, information security, audit, compliance, and governance, which sort of cover the entire IT umbrella. We have lines of businesses. There may be products and services which are revenue generators, which your customers interact with. You may have corporate systems which you use to do your daily business. You have end user computing, mobile devices, desktops, video conferencing systems, and so on. And each of these business units would have some functional skills: infrastructure engineering, software engineering, project management, operations, design and architecture, and so on and so forth. And these different functional groups need to work with each other in order to deliver business value. So what you're seeing on screen is a hypothetical example of how an idea may make its way through various stages, with each stage adding some business value according to their unique expertise until that thing lands into production and actually generates value for the business. The problem with this picture is, while these various blocks are actually functional skills where everybody brings their expertise to the table, in most IT organizations, they are also organizational units. There are different departments or groups. And when you have work artifacts or ideas or information moving from one organizational unit to another organizational unit, there are a few problems. Turns out, when you create a department or an organizational unit, you not only are putting together with like functional skills in one place, you're also deciding what kind of communications will happen very naturally, and what kind of communications will require an artificial process. So for example, in this hypothetical case, we have a development and engineering group, and they're great at development and unit testing. They're going to be talking to each other. They're going to be able to share their work artifact incrementally. Hey, I just finished this bit of code. Could you do a review with me? Or I just finished this little bit. Could I hand it over to you while I go look at something else? And information flows very easily, and people benchmark themselves against each other. But let's look at design and project management, for example. If they are in different organizational units, they feel like communication needs to be done in a formal process. Design may spend a lot of time, taking an idea and working on a really detailed design and architecture specifications. And they may think, we are going to put a lot of attention in these particular aspects because there were problems in a past experience. I'm going to spend a really good amount of time so we don't have those problems again. And they hand over the design doc to, say, project management, who now need to take the design, break it down, create a plan. And project management comes back, well, you spend a lot of time detailing X, but I need details on Y, and I can't do my project planning without it. Could you please do a new revision? So there are several problems in this picture. One is we have functional silos. Communication between silos is difficult. They slow changes down. It takes longer to hand work artifacts from one stage to another. Not only does it take longer to move work forward, if there is any issue with the work, feedback takes longer to come back. And all of this results in changes being slow. When changes are slow, people try to bunch them up. Instead of saying, OK, I'm going to do small releases with a few features again and again, people tend to have these giant releases that go into production with lots and lots of changes. And each of the change has a potential, has a risk of something going wrong. And what happens when you make lots of changes and push them all in one go? A lot of things can go wrong, right? And so people fear changes. Another problem with these functional silos is people tend to have different, they measure their performance differently. For example, engineering is typically measured on how many new features they produce, how fast. And they like changes. They want to move things fast. Operations is often measured on how stable the production systems are. And they hate changes. They want to slow everything down. They would not let a single change happen once the things were running, right? Now, individually, these KPIs are good for these different teams. But organizationally, we need a balance between moving and breaking things versus having stability. And there's no single place in this particular picture where you see somebody owning ownership of the entire thing, right? I put it to you that if you want to move fast and have stability, we need to break these functional silos down. How do we do that? You may have been hearing this term, DevOps, right? Again, I put it to you, if you looked at that picture, it's not really developers and operations, it's everybody in the value stream who is involved in moving things along from an idea to where it actually generates business value. So we should all change the name to something really long and complicated, DevSec, Ops Security, and something. Point being, you need to bring people together, and instead of thinking of functional skills as departments, you think of teams owning a project with different functional skills. And you apply certain DevOps philosophies, right? Quite a few there. Different people will give you different ways of looking at how to implement DevOps. I classify them loosely in 3 buckets. One is, you saw that there was a workflow. You need to take a series of steps to optimize and improve the workflow. And you'll never get done. You'll always have some issues, which means you also need to improve the way you get feedback. It should be super easy for people to say, here's an issue. Here are a few ideas about it. Go do something about it. And finally, we need to build learning organizations. Organizations that do not accept the status quo as, being this is how it is, but are constantly experimenting, measuring, seeing what works and doesn't, and trying to improve, again, the workflow and how we improve feedback. And while these are philosophies, it's good to have philosophies, how do we actually execute them? So these are, in my opinion, the ways, the actual practical things you need to do to execute those DevOps philosophies, right? So for example, we need to break down silos. Well, how do we do it? We create teams differently, and I'll talk a little bit about that. These teams need to have a sense of ownership and shared responsibility. Like, instead of saying, that's not my job, people ought to be saying, here's what I know about the problem, right? Here's how I can help. Automation, so while starting a project, how do we deploy the project? How will we test it? How will it behave under load? Those kind of things should not be afterthoughts. They should be part of the process from the very beginning, right? Everybody should be involved. When design and architecture is being done, operations should come and say, in our experience, these are the things that go wrong in production. So while you are architecting and while you're writing code, think about those things. How will we troubleshoot things when they go wrong in production? And so on and so forth. And of course, knowledge and judicious use of tools to help you along the way. And automation is one of the key things you could be doing to reduce your operational burden, improving reliability, improving security, and reducing costs. The end result should be that instead of having infrequent giant releases full of lots and lots of changes, you should have small releases with few changes, so reducing the risk of each particular release, and you should be doing them very frequently. Now, you are thinking that this was supposed to be a migration track, right? And what does that have to do with migration? Well, the way I look at it, and when I look at organizations doing migrations, it seems that when they start out, a lot of different functions who historically have had very formal processes for working with each other suddenly need to come together, pool knowledge, creatively come up with ideas, critically look at the plan, and help each other out. You need different people to work together. You have to break down those functional silos. Why not adopt DevOps, right? Also, when you're starting off with large migrations, you start off step by step and you learn, and then you change your plans, and then you try again and you learn more until you gain some confidence, and until you have sorted out the best practices and the standards that actually work for your particular organization, right? So again, DevOps, that's what DevOps is about. So how can we break down those functional silos? We go back to a hypothetical IT organization, and we move things around a little bit. So what we do is we truly treat functional skills as functional skills, not organizational units. We put the various skill sets that are required to execute a project successfully into line of business applications, and also create a team that is responsible for extracting standards and best practices and sending them out to the wider organization. And we can call it whatever you like. I've put Cloud Center of Excellence. You can call it the DevOps team. You can call it whatever you like. But the point is that every line of business application should have all the functional skills working together as one team to execute successfully. And you should have another team of perhaps people who have executed multiple projects, have had more experience than others, helping them with best practices and standards, and also learning constantly from ongoing projects. And we put those same skills in the umbrella governance functions so that policies, compliance, they are informed by real experience. Like, we have this policy goal, and how do we translate that into action? What are the specific things we need to do? And information needs to flow both ways. And the outcome of that information flow, those communication, now needs to be not, checklists that you just need to follow, but standards and best practices that are being updated frequently with real experience on the field. Education and training to newcomers and existing teams on what are the best practices and how have they changed and what is new. A review. If people are just following the standard practices, the time to do a review should be dramatically less. You only have to look at the deviations and what are the reasons behind them. And of course, investment in tools. I mentioned tools and automation are an integral part of achieving high reliability, low cost operations. So the Cloud Center of Excellence, in conjunction with governance, is responsible for establishing the automation tools and the best of breed things that other teams can use to reduce the time and effort. So that was theory, but does it actually work, right? So Puppet Labs have been doing annual DevOps survey for quite a few years now. In the last year, they found that organizations who have adopted DevOps actually are able to make deployments up to 46 times faster, more often than they used to before. That's a lot of deployments. So the stability should be really, really bad, yeah? Well, turns out that they actually reduce their failure rate. So they deploy more often, but things don't go wrong as often, dramatically less. Business value is delivered faster. So from the time an idea comes in, from the time first line of code is written, to the time it's actually delivering value in production, that's dramatically reduced. And people have more time, actually. Even though they are doing more deployments, more frequent deployments, and they seem to be, their ideas seem to be making into production more often, more quickly, they still have more time to spend on actual, on those activities which generate business value, instead of perhaps doing, writing up checklists on whether they followed certain practices or not. So if you're convinced that DevOps actually works, you may be wondering, well, we talked about migration of infrastructure. How do we migrate our organization to DevOps, right? So here's how I think about it. Just like migration is phase-based, and you start with a pilot, and then you get best practices, and you go into production, you can do the same thing with DevOps, right? Choose a project. You will do that in your migration phase anyway, right? In one of the activate phases, you'll be choosing 1 or 2 projects where you are going to apply your learnings. To execute that project, create a DevOps team. If you have ad hoc processes that are only in like people's heads, that only this person knows how to do that, document them. Make sure that other people try it out, and your documentation, when your documentation reaches a stage where anybody could just go through that document and actually execute and get the same results, you're kind of done with the documentation. That's your baseline. You start measuring things which are not just about, say, lines of code or how fast things run, but how long does your process take? How often when you deploy do you see any errors and you have to roll back or take corrective action? How long does the deployment take? You have to define what metrics are important to your organization. How do you measure your own success? Go and measure those metrics. How are things actually working now? And that's your baseline. So once you have your metrics, you now need to decide which ones of them will you focus on, which of them are the most important to you. So pick one. Automate some things that will help you reduce or improve that metric. Go and measure again. See whether the metric actually changed. If it didn't, it's time to have that's a great learning actually. Why did it not work, right? Sometimes it's more beneficial when you try and think about why something did not work than if it just worked. But regardless, you keep trying to pick a metric to improve. Think of a project. It could be an automation project, could be something else. You go and implement it. You measure and compare, and after a while, you'll get you'll be in a rhythm. Things should it would look like things are working. So it's time to extract those best practices. You have learned what you could from the pilot. It's now time to take it wider across the organization. So you establish these battle-hardened veterans are now the kernel of a cloud center of excellence who are going to do it for the wider organization. You create what I call a landing zone in AWS, where you have collected these best practices and the starting checklist and how to go about things and what we learned. And you have also created a feedback channel. This is where other teams can come and say, this didn't work for me. Could I get some advice on this? Or here's what I found. Would you want to change, some process or add some advice? It could contain templates that people can get started with quickly, processes that are known to work, best practices, advice for different kind of scenarios. And then you take this and you go and educate the wider organization who starts working on projects. Like there will be thousands of applications perhaps. They need to pick and start executing. These applications could be line of business applications that the company depends on for its business. Could actually be platform services or infrastructure that are like shared across whole departments or business unit. And it could be tooling. All those toolings that we talked about, they are also applications that need to be deployed, that need to be maintained, whose errors need to be fixed and improved, right? So that's a process. Now let's hypothetically take our DevOps principles and use them to solve some problems. Here's a common problem in many organizations who have development, QA, and testing and production stages, that the machines or the infrastructure on which applications are being deployed start drifting from each other. And what used to work in test suddenly does not work in production because library X is of different version in test and production. Somebody updated it on test to solve a problem, forgot to update it in production. You can take all those problems away. You can reduce this entire class of problems if first you have very well documented processes that can then be automated. You cannot start automation without having some kind of process that you have tested well. Automation can not only automate the deployment of your application, it can also be about how you set up your infrastructure. And cloud makes that easy. Here's another problem, right? Programmers are committing code to version control, and things work individually on their machine. But when you try to, anybody tries to do a full build, things don't work. So engineering teams have set aside this integration week or integration day where every programmer will sit and try and make sure that the build works and try to figure out. And by the time there are already dozens or hundreds of commits, and when something breaks, the build doesn't work, it's kind of hard to figure out which particular commit needs to be tweaked, right? Or the build works, the test work, but deployment has failed. Why? Because somebody mistyped a command or forgot to type a critical command, and the effect of that wasn't felt until much later during the deployment phase. So we have been busy for hours deploying things. Suddenly something doesn't work. It's really not obvious why it's not working. Turns out it's because of some mistyped name of a config file or some parameter that was done 24 commands before. And again, we can remove this entire class of problems by investing in automation of our processes. So how our code is built, unit tested, integration tested, stress tested, or load tested. We can use continuous integration and delivery pipelines. We should have automated deployments, and we use exactly the same automation, the scripts, to deploy to testing and production. So there is no more mistyped commands or missing commands or something like that. It just has to work with only the changes of a few parameters or variables, right? Here's an example of how an organization did it. So what you see in the picture is a police siren sitting on top of a build server. So when somebody commits code, it automatically goes off to the build server, which then builds it and runs unit tests, maybe other tests, and if something fails, the siren starts wailing and the lights start blinking. It's impossible to ignore. This organization takes the health of its build pipeline really seriously, and that's really key. If you have a process like continuous integration, and you don't actually pay attention to the health of the process, like are people really respecting the fact that my build pipeline should be healthy, my build should be working? If somebody, it is going to happen that people accidentally check in code, which kind of doesn't work. Or maybe not accidentally, but they don't know that they have been changing code that somebody else has also modified. Well, regardless, it is important to make sure that your processes are healthy, and it's important to surface and make visible what the health of the process is. So we have system monitoring tools that monitor our production websites, whether they are up or not. We need to have tools, we need to have dashboards that tell you, well, how long does it take from checking in code to the time an error is detected. And if there are no errors, when it is deployed into testing and some kind of integration test is done to make sure that the application or system works end-to-end, not just unit tests. How long does that take? And we need to not only spend time on writing code to implement user stories or do bug fixes, but also on how do we make sure that our build pipeline is giving us the feedback that we need quickly. Are we catching the most common errors as fast as possible, right? Before doing too much testing on it. So you need to refactor the build pipeline just like you refactor your code. Another tenet of DevOps, improve feedback, and that's, I just mentioned, build pipeline. The health of the pipeline is an important feedback. It tells you whether your process is up or not. But of course, your application goes into production. You wrote your code with great care, but is your website up? And if it's, maybe it's up, but it's slow. If it's slow, why is it slow? Something is breaking. Where is it breaking? All of these things take time, right, to discover. So you'd rather not leave it to chance when things are really down. You need to invest in things which are not just code. You need to invest in monitoring and logging. You need to invest in setting up the right dashboards that give you a bird's eye view of what's going on. And really, you would have seen a lot of these products and articles about them. What we are actually doing is applying one of the DevOps principle of increasing visibility and amplifying feedback. And we can take that principle, and we don't have to just do it with this tool. We just apply it everywhere. Wherever there is a potential of something being red or green, something going right or wrong, we need to think about how we take that and make that information visible to everybody, right? So we're talking about logging. Now, back to AWS. How does AWS fit into this? AWS provides you with platform services and tools. It helps you with managed services, tools to do operations, tools for monitoring and logging and dashboards, and automating your infrastructure provisioning, infrastructure as code, right? So you take this tool, and you apply those DevOps principles, and you end up with an organization which has migrated from what used to work very well when requirements were stable, the business environment did not change very much, to today's world where business wants you to move fast and also be reliable and also be secure, right? If there is anything you take away from this session, I would urge you to think about things like this. Understand that large-scale migrations demand from you that you move with speed, that you adapt constantly, and you learn. We have a migration framework. Utilize it. We have experts out there to help you use them. And while you're doing your migration, think about your IT organization, because functional silos create risk for your migration. And with that, that's the end of my session. Thank you very much for being such a great audience. Thank you.